after the presentation that you don't like the textbook way of knowledge, and because there's so much information on this and I hadn't introduced it to you, I thought it would be a better way to come and tell you what it is, what are the kinds, what are the different types. And I don't think that went really well. So today I have changed my strategy. Today I would, instead of using a lot of terms, a lot of jargon terms, I would just share things that we've spoken about previously and just recall them, or we will study a few case studies and then we will use them to understand what's going on. So it's not important that you know what phytoremediation, phytoextraction, phytoaugmentation, everything else is, but it would be important, at least for the case study that we study, that you know that if plants were used, what was the mechanism happening. And okay, if you don't remember what we studied in Monday, then I think it's probably very difficult for you to remember what we studied with reference to heavy metals and their bioavailability with the change in pH, and all of those concepts that we've learned from time to time. Maybe just bring it back and try and learn it. All right. So, but like, think out of the box. Don't think traditionally. And if I've missed something and you know it, and if you have any ideas, even if it's a wild idea, just throw it in like, raise your hand and share it with your class. And I think that'll be very, very interesting. So let's not waste any time. And I'll start the presentation. Okay, so the reason why I started with soil pollution or soil pollution control techniques, was because we studied agriculture recently, and I thought the knowledge would be a little fresh with you, and we've discussed them from time to time, so I thought it would be better to start with that. And again, I would expect or ask you to give me a few solutions, because we've already discussed them with reference to agriculture in our previous lectures. We care about this resource because although it's renewable, it takes a lot of time for a layer of soil to be formed, for a layer of arable soil to be formed, which means that if there is any oil or hydrocarbon pollution or any other form of heavy metal and in industrial waste contamination on the soil, and that topsoil, which is important for agriculture, is damaged, it basically hampers a lot of other things for the planet, not just for the wildlife, but also for us, because our food security depends on this natural resource. And we care about it because it impacts so many other things. If the soil is degraded, if the soil is polluted, okay, why don't I throw this question to you? If the soil is polluted, what kind of impacts would you see around you? And you can use this information that I've put in as a key if you want to talk about it. Just raise your hand and then discuss. Daniel.
Ma'am, we would not be able to use it for agricultural purposes if it's polluted.
Exactly. Fateh.
Daniel already mentioned my point, but I'd like to go into much more detail. So, economic loss: if the land is unusable and you cannot grow crops, particularly if you are in an agricultural country, this will ruin your economy. For example, if there is large amount of soil degradation in Pakistan that is affecting production of cotton, this would mean that we would have lesser cotton to produce textiles from. Textiles, which is already one of Pakistan's biggest exports, would drop drastically. A current account deficit would rise up dramatically.
Absolutely, Fateh. Amen.
I feel like our quality of nutrition would be affected, and apart from that, since we'll be consuming unhealthy crops, right, that won't be healthy in the longer run of things, because it would affect our for instance our digestive systems or internal systems.
Yeah, Yeah, so the food chain, any pollutant becoming a part of a food chain would impact all the living beings on the planet. Atka.
Yeah, my point was similar to what I think Eamon talked about. So, I mean, I wanted to say that the pollutants in the soil, particularly, they enter into the food chain and they can result in many diseases and excess mortality in humans as well. And it can have both short-term and long-term effects. And um, long-term effects I remember reading somewhere that it can actually lead to cancer. So it's actually very harmful.
Absolutely. Seema.
Okay, so I had a point that degraded lands are often less able to hold the water, which can even worsen the flooding and increase the chances of flooding, and which can have further consequences as well.
Yes, that is great. Hassan Shahid.
This time I thought that from the economic point of view, that if the soil is polluted, then if we think about it from a construction point of view, that if we like construct a house, so that the house or any sort of building it can like uh, खराब वो जो है वो जमीन के अंदर जा सकती है, तो इस तरह का मैं एक पॉइंट था मेरे दिमाग में. So yes,
Yeah,
if
you're
soil
all
is
right.
not of that
Yeah. So you're all
worthy
right.
quality.
And then, there are other things that we've discussed, by the way, which is that if, for example, soil is degraded, if agriculture is not practiced properly, if the soil quality has degraded and plants cannot grow there, if our practices are not right, then what happens is it impacts everything else, right? So, for example, we said soil is a sink for carbon dioxide. And if soil is degraded, then that sink for carbon dioxide would be lost. That ecosystem service would be lost, which means that we will be, by degrading the soil, contributing to climate change even more. And the points on flooding and everything else were very, very correct as well. And then if soil is polluted, even though it cannot move, water and air can move those pollutants around as well. And I think I've put an example of persistent organic pollutant somewhere in the slide, so you would be able to see it. But again, that impact on human life, loss of biodiversity because life is lost, and the life that animals depend upon is lost. So everything, again, is interlinked. But if we think of how is the soil disturbed or how's the soil degraded, and how those degradations then impact other areas. This slide and this report in particular of FAO, I had to use a lot of resource from here because it was updated and there was newer information. And then I also like the way they integrated things. So if you're using pesticides, if you're using herbicides, if you're using fertilizers, how does that impact the soil? But how does that also impact the water quality? Because then the water takes all the nutrients with them, and you've studied eutrophication and all the other things. You've also studied acid rain, and that and then how that rain kind of comes back, degrades the soil, and then could contaminate the soil, and how that could then become a part of the soil and impact life there as well. Any industry, any industrial waste then also has an impact. We've studied all kinds of renewable and non-renewable resources. All of the non-renewable resources are extracted from the ground. There we studied, we studied fracking, we studied disposal of nuclear waste, we've studied disposal of untreated wastewater. All of them impact not just irrigation, but also soil quality and the entire food system. And similarly for oceans, I think if chemicals go to the ocean or whether salt is coming back to the land, they're both degrading the land and then in turn changing lives. So just for you to make those extra connections that I hope that all the knowledge that you've taken from this course would enable you to make. But if we just focus, for example, I'm not thinking about every other industry, but just the agricultural resources. So from agriculture practices alone, how is the soil polluted? And if anyone wants to speak, they're more than welcome to raise their hand. We put livestock there, we use fertilizers, we use pesticides, we use herbicides. Sometimes we just irrigated with wastewater, and that wastewater could come from industries and homes or municipalities, and that then results in degrading the soil quality. And also, like any chemicals that are being discarded there, and all that pH regime change that we had studied with heavy metals, that how once you bring in something else becomes available to the plant, and then if we eat that plant, we could be impacted as well. The slide about synthetic fertilizer use, I kind of put it there because in the past few presentations, we've talked very much about nature-inspired agriculture, or agriculture where the input is very, very low, right? And we were saying that, okay, farmers are now educating themselves and farmers are practicing what we call conservation agriculture. And this practice, the zero-till practice and everything else in any ways had started in the 1970s, past the Industrial Revolution, but it hasn't picked up yet. So even though I taught you all of that, and even though there's a great emphasis on that kind of nature-inspired practices, with respect to agriculture. But if you look at that graph, it basically tells you that the use of synthetic fertilizers is still increasing. So we're still feeding junk to our soil in terms of food, and we're not utilizing the natural biogeochemical cycles or the ability of microbes to fix a lot of things for the plants. And we're manipulating it, and we're continuously making them dependent on synthetic fertilizers. And the use of synthetic fertilizers, if you start using it on the land, you have to kind of increase the quantity every year. And anyone who's practiced farming would know that with each year, if you stop organic farming and if you switch to synthetic fertilizers, the quantity is simply going to increase because the soil quality has degraded. So just a heads up that we are going towards the right direction, but it's difficult, as Dr. Mahmood had mentioned in his presentation, to fight against these corporations that are still selling practices that are against the environment. Now, again, I'm going to ask you to speak about the solutions for agriculture and soil pollution. And we may have discussed it in the last class, but I just wanted one of you to re-emphasize, how can we stop degrading our soil? How can we stop soil pollution? And what should we do to keep it safe? Hassan.
So one of the ways mentioned over here is intercropping, and if I remember correctly, that was basically planting different kinds of crops, each of which have a different function. Like one of them can hold on to soil nutrients or the soil composition better, and others have like water regulating capabilities or nitrogen fixing capabilities. So basically just different types of crops, each having their own function to help the yield.
Absolutely. Does anyone else who hasn't spoken before want to speak? Rafi?
Ma'am, like how we discussed that one thing where you churn the after kya kehte hain, you use the land, you churn it, and you turn the ground upside down, and then you use the same land. Wobbly technique. I forgot the name.
Tilling, yeah, or tillage, yeah. So basically, yes, the ideal practice would be zero tillage. Hassan's asked about the units. So basically, it's in amounts, Hassan. So when you use fertilizers, you're kindly just using it in kilograms, right? So for global scale, it would probably be metric tons or million metric tons or whatever amount you use, but I think it was million tons for the graph that I'd shown you. Yeah, and then Iman's also saying that we should stop monocropping, absolutely. But I think the key is the no tillage or zero tillage, because as I mentioned in the previous class, that's the carbon sequestration that we all want. That's the kind of service that we want for the soil to have, for more and more carbon to be captured via the plant into the soil. And when that happens, so for example, even if it's organic, in the organic form, and it stays there in the soil, degrades itself, it's there, it's kind of a carbon sink. But when we make it bare, when we topple it up, when we till, we disturb it, and we disturb the life there. And that's why it's a practice that's discouraged. But the farmer who we had met, the organization called Pedavar, who we work with at the center, they're all encouraging farmers to practice this, which is zero till. And also what I was saying about not burning rice before you crop the next. It's like you use those, you've created that kind of machinery that helps you crop without disturbing the soil too much. So minimum till or zero till without changing the landscape too much. And whatever you do, take inspiration from nature. Think about how this could happen in a forest. Think about how this could happen in a natural setting. And then just do it there without too much disturbance. And why is soil important? Because a lot of soil chemicals can reach down to groundwater as well. So oftentimes what soil pollution is also groundwater pollution. So if the soil is polluted, and if there are chemicals that can leach heavy metals into groundwater, then soil pollution and soil remediation or treating soil also means groundwater pollution and groundwater remediation. So just think of that as well. Don't think that we're only talking soil right now. And people have been interested in finding out, what's going on with certain pollutants. With persistent organic pollutants, I often told you that they are persistent. They stay in these kinds of dioxins that we've used in agriculture a lot. They stay in the environment for a very, very long time. And most of you, whether we talked about microplastics or ozone or anything else, wanted to know how it was able to travel so much. And I had taught you the weather patterns at some point, because I wanted you to be able to make that connection about how certain weather patterns or wind and all of those could impact it. But also when it comes to control, so for example, if the wind is blowing it, then you can think of what kind of agricultural practice would stop it. So I would say something like agroforestry, where you're putting a boundary line of trees for a certain land could probably stop it. So just think about those. But also it won't be possible to contain everything. There are, as Han and Paul will know, there are many chemical pollutants that are volatile in nature. And that means that they can't stay on the ground. So they just evaporate and then they go to the atmosphere, and then it's difficult to contain them. And then the approaches that you take, for example, in terms of life, whether it's bacteria or other kind of life, is to hold it there, is to stop it from moving. But I just wanted to share this with you for you to look at, how could it stop? For example, if the deposition rate is increased, then the evaporation rate, then how could you stop it at a certain point and stop it from spreading further? And that's not just an information for scientists, but also for policymakers as well. Yes, Hassan. And this one, so last time, because I introduced different terms to you and I was explaining it to you in great detail, this time I've just put it in different compartments, and I won't be explaining everything because we'll be jumping to the case studies. But there are different kinds of ways in which you can treat soil pollution. And they can be physical. So for example, you just use a simple thing to contain it, or an electromagnetic plate to just be there and take that hydrocarbon out. Or it could be chemical, where you're using certain kind of chemicals or certain kind of conditions for reactions to take place chemically, or you're manipulating the pH as we had studied before. Or it could be biological, where you're either putting a plant, or it could be an extensive bioremediation technique. For example, land farming or biopiling, they're all techniques where you literally take that site as a bioremediation site and put. Atka, do you have a question?
Yeah, I'm just wondering, I'm a little confused about something. It might be fairly simple, but how do we distinguish soil degradation from land degradation?
So it's the
So
same.
that it's the same thing?
Yeah, it's
because okay. All right.
But why would you think they're different? Because maybe you have a point.
I don't know. No, with land degradation, I've always referred, like I've always linked deforestation for some reason. Like
Yeah.
that's the first thing that comes to my mind when I think of it. So usme, since we haven't really, like, I don't know. So I was thinking maybe it's sort of different from that, in some ways or the other, because this is more related towards agriculture.
Yeah.
Um,
Yeah.
so yeah,
So maybe
that's
what we can do is, just for your understanding, let's put soil as a medium where food is grown, and let's refer to everything else as land, right? So that way it would be easy for you to think, because we are manipulating this particular resource for the reason that we're growing crops for ourselves. We are just referring to this as soil, and everything else, everywhere else in the world, we'll just refer to as land. Okay. So yeah, like in a way, if you want to, you can distinguish them, but I would like to keep the entire lithosphere as one thing, as one sphere of the environment. But I think you're also right. Depending on what you want to do, you could compartmentalize them into different areas as well.
okay.
Okay.
Thank you.
You're welcome. So, but these terms, do you want me to go through them one by one, or are you okay if we just jump to the slides? Or would you like to add on to one of the points because you've read something somewhere and it excites you? Okay, maybe I'll just take one. So for example, air sparging is when you create a vacuum, take pressured air into the soil or into the groundwater, and make the hydrocarbons to escape. So they are, if the hydrocarbons or if the oil or let's say petroleum or diesel has become leached into the, or if there's been a crack and it has gone into the groundwater or into the soil, then you kind of create that way, that vacuum, and then sparge it with air and with pressure, take it out, from the ground, right? So that's one. Washing and pumping and treating simply is that because it's difficult to treat groundwater under the soil and therefore the soil around the groundwater, you would just extract it, pump it out, treat it on the surface, and then maybe use it or put it back into the soil. And hydrolysis is basically simply degrading something in the presence of water. So you use water and then you make something interact. So maybe you can use complex hydrocarbons, bigger hydrocarbons, which have longer chains. You interact them with water and then they degrade into smaller hydrocarbons that are easy to degrade. pH manipulation, you sort of have an idea. Land farming is when you, for example, take a land, it's completely contaminated site. Now what you do is you create a lining. So let's say you use a very thick plastic lining where you're making sure that the contaminated soil that you put on doesn't leach anything into the soil further. And you are treating that as a land where you are doing a lot of activities, where you're farming or treating or exposing it to oxygen and light to treat that contaminated soil and turn it into better, clean soil. And what else? Some of them we'll study in the slides further, so I'll just leave it. Does anybody have a question up until this point? I can see that Azhan's expanding the boundaries of science and technology, which is good. Yeah, organic fertilizers, thank you, Taiba. Any questions? No? Okay, so now we'll look at 3 case studies. And all of these case studies are, of course, examples of soil being contaminated by a certain contaminant, mostly hydrocarbons, and then how they treated that particular soil. So let me just take this chat box away. So this Côte d'Ivoire, if I'm pronouncing it right, is it's in Africa, somewhere in Africa. They had petroleum oil and lubricants problem, and the major reason for that was, of course, it was the UN was always there. They have a lot of peace instability, and therefore UN peace mission goes there and they're working there all the time, which means that they take a lot of mechanical stuff with them, or they need those temporary residences where electricity is required and mechanical operations are required. But when you use such operations, that means that a lot of oil and lubricants are also transported because you're generating electricity or any other thing that you need for a camp. And that then results in contamination of the soil, because oftentimes when you're leaving all the things behind. Or sometimes when you're operating it, you're not really operating it carefully, and then that puts a risk of polluting the soil. So what happened was that this particular area or this particular region had a lot of petroleum oil and lubricants in the soil. So let's say if we use an relatively easy medium, they had 90,000 ppm of POL, and then after treating it, they brought it down to 1,000 ppm. But how was that possible? Like 90,000 ppm is a huge amount. It's like 90,000 milligrams per liter, basically, of these petroleum hydrocarbon in the soil. And they had to bring it down to very lower levels. And they did it through two techniques. And both of them had, first of all, when you know that the soil is very, very contaminated, you have to remove the soil because there's no other way to treat it. If you treat it there, then again, we have that problem of during the treatment process for chemicals to leach down, which we do not want, because we don't want the surrounding soil to be contaminated as well. So the first thing that they did was that they removed 1,200 tons of POL contaminated soil. And then they replaced that particular soil with a fresh soil, took this and used these concrete mixers. Because in biology, I think Samar and others who are from biology would know, you're always using oxygen and mixing to increase the degradation activity. And I'm sure this is true for chemistry as well. But so what they did was that they used these concrete mixers because they could continuously mix this, and they're generally designed to mix soil, to make sure that this contaminated soil and the activity inside, whether it's using microorganisms or other manure, could increase. So the topsoil was removed, put in a concrete mixture, and then the next thing that you do is you give food to whatever's degrading it. So let's say if the chemical is able to degrade oxidize in the presence of oxygen, you would just expose it to oil. But in this particular case, it was microorganisms. So to increase the concentration of microorganisms, you need to give them good food, right? So phosphorus and nitrogen and carbon and all of that. So what they then used was they used natural material, which is the poultry waste and surface active materials, natural surface active materials. So poultry waste was used as a growth medium or as food for microorganisms that were present in that concrete mixture. And by mixing it, they allowed for them to remain active and to be able to degrade the contaminated soil. And within 2 weeks, they were able to reduce the TPH, or the total petroleum hydrocarbon level, down to 95%. And after that, like once you know that the soil is relatively better, then you start growing crops on it. And the best way for soil remediation or soil reclamation generally is to use crops that are local or natural, because then it comes back to its natural state or its natural habitat. What is Azhan saying? Azhan, you can just say it out loud.
So, ma'am, basically, I want to say that it depends upon the Lee-Chatelier principle, which is basically talks about achieving the dynamic equilibrium, like by disturbing the change in the condition, the position of equilibrium moves depending upon the initial concentration of the reactants in the products.
Right. So how would this? So if you think of this particular environment, how would it happen here? If you could apply the same principle here.
So that's the main concern right now for me. Like I was like, it depends upon the condition of the soil and the contamination that it already has. For some contamination, I believe it will be direction will definitely move forward, but it's not necessary. I just want to say this.
Yeah,
Because
even
it depends on,
yeah, so even reduction is a treatment process in soil remediation, Asan. So it's
yeah,
not necessary that only oxidation is used to remediate the soil.
yeah.
Reduction can also be used to remediate the soil. So sometimes, as we read in the last lecture, that sometimes when you are reacting these different chemicals, they can become something very difficult as well. So more difficult than what the parent compound was or the parent pollutant was. So of course you have to be very, very knowledgeable to know that as well. Like whatever you're doing, you have to do it consciously, and you have to be educated enough to do that. Generally, because for microorganisms you require air, you require aeration. It's a general practice that you would expect for the environment to be more oxygen friendly. But for certain reactions to take place, so for example, if it's being reduced, or if it is being oxidized. So for example, if Fe2 plus is becoming Fe plus 3, so ferrous to ferric, right? If I'm not wrong, then if that's good for the environment or bad for the environment is a decision that someone sits and makes at a particular point. So we're oxidizing iron from one form to the other to achieve what? We're oxidizing mercury from one form to the other to do what? So for example, we could oxidize mercury and make it, or reduce mercury and make it zero in its zero valence state. We could just release it to the air. But if the objective is to not let it escape into the air, then we probably would need to oxidize it instead. So I think those kind of decisions need to be made, and you're absolutely right. There's no set principle that this is the right thing. And again, even for those equations to happen, the environmental conditions need to be right. The pH, the temperature, the quantity, the equilibrium, and whatever you're talking about, they all need to be there. So yeah, thanks for putting in some chemistry for your class fellows. Okay, so now that soil is contaminated, the approach that they took was they took the soil, they characterized it, they screened the site, they looked at it, they used a certain kind of equipment to remediate it. They looked at the interactions. They used certain kind of food for the microorganism and the protozoans or whatever that were using the nutrients to degrade the hydrocarbons or the petroleum in the soil. And then they did it in batches. So of course, the concrete mixer could only take a certain amount, so they did it in batches. And then they used the microorganisms that was acclimatized to in the batches to follow, and then recovered the soil. And after that, they practiced phytoremediation, where they put the local grass onto the soil, and then they had to monitor it for several years. So when we pollute the environment, when we contaminate the soil, when we do something, we think that it's very, we think that someone's going to take care of it. Sometimes these practices take 10, 20, 30 years, because you have to continuously monitor it to see that everything has been remediated. Just because plant is growing there doesn't mean that the soil is healthy, because some plants have the ability to grow in toxic conditions, and some plants have the ability to grow in very, very toxic conditions. So that's why there needs to be a monitoring, and that would be the practical approach to remediating the soil, not just bringing populations here and telling it's now safe to live here. And the second case study is of an oil polluted site in Siberia. And the reason why I chose this again was, for example, to tell you, to make that kind of environmental connection about, okay, a particular treatment mechanism has been found out. A chemist or a biologist has in the lab found out that you can use this equipment, and you can use these plants, and you can use these bacteria, and you can grow them, and they would be able to take care of the soil. But suddenly there is a land polluted site in Siberia, and it's very, very cold. Or even, let's say, to many regions in the north of Pakistan. So for example, the biogas plant that we had seen in one of the villages in Hunza, it didn't operate in the winter, because it's very cold there in winter. So if you are designing something thinking this could happen round the year in Hunza or Sawat or anywhere else, that's not going to be the case. So those conditions very much depend on the environmental conditions. And how you achieved remediation of land in the previous case study does not necessarily apply to a similar kind of land in Siberia, because the environmental conditions in both areas are very, very different. That's perhaps a warmer region. This is a relatively colder region. So now what happens is that, you know, this particular region, the tiger zone in Siberia is where Russians extract their oils from. And which means that because all the oil is going from here, a lot of pipes are originating from here as well. And I taught you laws and policies and limits for the same reason that when those laws did not exist, people did not care when there were accidents. People did not care when the pipes exploded somewhere, or if there were leaks somewhere. If the leak was so tiny, so minute, they wouldn't care much, depending on how big their resources were. So that's what happened. And I think Fateh would like this term. Historical heritage was something that I learned. For example, if I'm a new oil digging company, or a company that's there to explore more oil sites, if a company before me that is operated there has used or extracted something and then wasted or discarded some oil, or, you know, the initial thick mixture, if they've discarded it on the soil, if they leave it there and I'm the next person coming in and using the same site, now the soil was already contaminated by somebody else. So the kind of pollution that exists there in this particular language is called historical heritage, because they've left that heritage for me, for someone who's just come in a relatively stricter conditions, in a relatively tight actions on consequences. For example, I might have to pay for polluting. I might need to remediate the soil before I leave the site. They did not have to, but because they're passing it on to me, it's a historical heritage of pollution. So a lot of ecosystems were polluted. There was no action taken. And then when it started degrading life, because this region has a lot of swamps and wetlands, and when it started degrading life, when the number of species started disappearing, they got concerned. But then there was an issue. Like I said, the traditional pick up the soil, use that technical machine to treat it, because, you know, microorganisms need a certain temperature. To ensure that temperature, they might have needed more power supply or something else, and that would have made it expensive. Or to use certain chemicals, it might have become an expensive process, because I'm thinking this probably is a remote area. So what they did then was they used the natural environment. So if, for example, the natural conditions were used to treat the soil. And the second reason why it had become so difficult was the ability of those wetlands, so those soils that are loose, they contain organic content. They quickly absorb these oils, they quickly absorb these pollution. And it was difficult to extract it then, because, as you know, to extract it, you probably need another chemical, or you would probably need more water to kind of pressure it. And then everything just makes it more difficult to remediate the soil. So taking the soil out was labor intensive. That was a difficulty. Using all the other conditions that had previously been used in all the other regions was difficult. It was economically not efficient. The soil, or the kind of conditions that were there, which was peat, it had a pH which was more acidic. And we know that in acidic pH, heavy metals become bioavailable. So that, and sometimes heavy metals are toxic to microorganisms. So that also was another problem. But what they did was they used the acid-base regime. So something that we studied with the pH, and I know now why I taught it to you then. So when you change the pH, then you can manipulate it a little bit. But if it's a huge site, and if it's scattered in certain swamps, would it be, again, economically feasible to put so much lime? So to neutralize acid, you put in a base, right? So would it be worth putting a lot of base in there to neutralize it? So all of those questions surrounded this problem. So what they did was they bio-augmented the pollution and they phytomeliorated it. So basically, So the concepts that were used in the previous slide, where you stabilize a pollutant. You kind of force the pollutant to not leave a certain environment. So these pollutants were forced by the plants that were native, that were natural, to not leave the surrounding, and were augmented or brought in close to the roots of the plants, and then they were used to phytomeliate. So they also provided, because there's anoxic conditions, so those roots acted as pathways for oxygen, allowed for those oxygen molecules to manipulate the hydrocarbons a little bit, but also allowed for the microorganisms present in the root zone or in the rhizosphere to be able to degrade it, because now they had the oxygen that they needed to degrade it. So all of that thinking had to take place there, and it was, of course, successful. And that's case study number 2. Any questions or comments so far? No? Okay. So I will just continue, because this one's the last case study and I don't want to waste a lot of time here. So basically, this is another site, and this site is a mining site, and it's in Spain. And again, it's also a site that has been used for mining for so many years. But with mining, you take what you want, and you use all of these mineral sulfides and other minerals that you don't need behind, and they are called tailings. And those tailings have no nutritional value, very little fertility. Using vegetation to get rid of it, because in the previous 2 we saw how vegetation had a part to play, but here the vegetation had little part to play, because the kind of pollutant that remained, which is zinc sulfide and lead sulfide, or PBS, was plants couldn't grow in their presence. So phytoremediation would have been economical, but how do we bring the conditions down to such that plants are then able to grow in there? So they'd used marble waste as a carbonate source to again neutralize the pH, because we know that acid mine drains are acidic in nature. So they used marble waste carbonates to neutralize the acidity, and then the metals were sort of made immobile, and then a pig slurry and solid phase pig was or the manure was used as a food for the microorganisms or plants that were residing there. And then that was used to treat the wastewater. So the local plants, because last time I hadn't mentioned the plants, and I think Eamon had asked what they would be. So the local plants were used, and then it was found that some of them were more efficient in removing them, in keeping them, in stabilizing them around their roots, and then removing them from the soil. So you continuously take them out and grow them, or just cut the shoots and make sure they continuously grow to take that zinc and lead out of the environment, to make the environment clean again. And that combination of marble waste along with the pig slurry or the pig manure worked really well for Spain, where again the temperatures could have been different, or the environmental conditions would have been different compared to the Siberia. So why do little actions matter? Because if I just have a bucket of wastewater, and if I put that bucket of wastewater into, if I have a mug of wastewater and I put that into a bucket of wastewater, I'm basically turning this whole thing into wastewater. And that's why it's important that I make sure that I don't put this mug of wastewater into the bucket of wastewater, because then now the wastewater has just increased in volume. And that's exactly what we are doing with all the practices. For example, us throwing all of our municipal waste into this nala that is passing by us. We are turning a nala into let's say if it was just a river and it was taking away clean water, by putting our wastewater in and eventually dumping it into Ravi, we are turning Ravi into a wastewater river. And the same could be said, for example, for dump sites as well. A lot of waste that can be harvested, specifically municipal waste that we studied, and municipal waste management, the food waste can be reused or used to make compost. But if we send it there, in certain quantities we need it there, by the way, for the same reasons that we studied in the previous slides. the microorganisms need food, and these are good source of food for and easy to degrade for microorganisms in the landfill area as well. But excess food and food in combination with, let's say, toxic waste, if it's industrial waste that's coming to the landfill and we are taking our food waste and combining them together, now it's a food waste that contains lead or mercury or arsenic, just because we've given them the opportunity to interact with each other. So this is why all the little things that we do at home, at industrial level, in institutions, really, really matter. Hassan's using other compliments as well. Okay, is Ali in the class today? Ali Heather. Ali, you better be in the class today. No, you're not. Okay. If Ali is not in the class today, that just doesn't serve the purpose. Does anybody remember? Because I also had given you a reading on how to make compost. So basically, Ali had done this assignment where he told how to make compost at home. So I put his slides to make sure he explains it to you. But since I'd given you a reading, if anyone remembers what you do with composting at home, then please raise your hand and let me know. Even if it's a guess, don't worry about it. And this time I'm not going to speak until someone raises their hand to explain it. Allah, have you guys decided that you will not talk today? Okay, right. So basically you just use the food waste from home, and you give it basically needs the moisture. So you would use the food waste, you'd make certain, Adeen, go ahead.
Yes, ma'am. I just remembered it when you started telling about it. So it is like these are like waste foods which are then broken down into inorganic compounds, and these compounds are then uh, serve as the nutrients for soil.
Okay, that's great. Does anyone want, Taiba, why don't you elaborate further? Yes, but that's right, Adeen.
Ma'am, I was gonna say the same thing. Like we make compost at home, and we basically use things like banana peels, and then we kind of leave it, and then we leave it for a while, and then we kind of deposit it outside. And I think it really helps absorb the nutrients and stuff. So I think that's basically all I wanted.
Yeah, so you're basically using all the waste, so kitchen waste, organic waste, waste that can be degraded or biodegraded. So this food waste, if you just leave it outside, it biodegrades, right? As it loses moisture, as it also, some of it will evaporate. Sometimes, it just shrinks in volume. So if you leave your apple peel somewhere, it would just shrink in volume. So that's what we want to do when we're composting. We are converting it into the soil, basically. So we're converting it into organic matter that can be made a part of the soil for plants to be able to utilize it again. And by doing that, we are reducing the pressure that waste that is put on the waste collectors. So if I have, let's say, if we are 10 people living in the house and we make all kinds of food and there's a lot of food waste, and every day the waste collector who comes to my house thinks, what are these guys doing inside? Even if I have a small garden, if I don't have a small garden either, I think you can just do it and then reduce it in volume, and then maybe give it to someone, maybe give it to the central garden in your housing authority. There are a lot of organizations, by the way, in Pakistan that give you the tools to do it. So for example, I think Trash It is a company that gives you a packet where you can just put it, it tells you the recipe as well. So they will tell you what to put in, and then you have to close it, and then it gives that condition to the things that are inside, and then it's composted and it shrinks in volume and can be applied to the soil as food. So yes, you're both right. Thank you very much. Aman, you did an assignment on e-waste. So how does e-waste find its way to soil, and why should we take care of it? Do you want to speak?
Yeah, man. मैम व्हेन जब हम कोई भी इस तरह की चीज़ यूज़ कर रहे हैं, फॉर एग्जांपल बैटरी, और इसके अंदर लाइक लेड है और मर्क्यूरी भी यूज़ हो सकता है, और इसी तरह इलेक्ट्रॉनिक्स डिफरेंट जो है उसके अंदर क्या कहते हैं, फॉर एग्जांपल कंप्यूटर के मॉनिटर्स हैं, वो मॉनिटर्स के अंदर भी डिफरेंट काइंड ऑफ मटेरियल्स यूज़ हो रहे हैं। तो जब हम उनको विदाउट प्रॉपर मैकेनिज्म के बगैर हम उनको फेंकेंगे, तो उसके अंदर जो सब्सटेंस है वो इवेंचुअली आके लैंड पे या सॉइल पे ही आके गिरेगा। और सेकेंडली जब हम बरी भी करते हैं लैंड के अंदर, तो जो हमने पहले पढ़ा था कि जब हम लैंडफिल्स के अंदर जो इस तरह के हार्मफुल सब्सटेंसेस होते हैं, तो वो ग्राउंड वाटर के साथ मिक्स होके आई गेस लीच कहते हैं उससे, उसके मिक्स होके फिर वो ग्राउंड वाटर के थ्रू वाटर बॉडीज में भी जाने का उनको खतरा होता है। तो इसलिए हमें लेकिन फेंकने के बजाय हमें एक प्रॉपर मैकेनिज्म की ज़रूरत है जो इस मटेरियल को पहले उनको इन सब डिवाइसेस से अलग करें और फिर बाद में उनको डिस्कार्ड करें।
बिल्कुल। तो वी नो लेड इज टॉक्सिक, वी नो दैट इनके अंदर अगर एसिड है या बेस है तो अगर वो सॉइल में जाएगा तो हमें पता है कि पीएच कैसे मैनिपुलेट करता है सॉइल की क्वालिटीज को। अब इसमें खुद ही लेड है, तो अगर आप इस लेड एसिड बैटरी को जो कि आपके यूपीएस में है, पहली बात तो ये कि आई थिंक ऑल ऑफ यू whatever devices you're using, just go and see what kind of battery is in there, because up until I had to sort of work out to find out what kind of batteries are there, I wasn't aware of how many kinds of batteries are available around me in the devices that we use at home. I've just given you a few examples here. Ab isme, cadmium is toxic, lead is toxic, acidic conditions are not good for the soil, alkaline conditions can be bad for the soil. So when you know all of this, and then you know that you're using certain things that would end up being in the soil, especially in cities like ours, where there's no condition to treat soil waste, no condition to treat wastewater, then what could happen to this. So make sure that all of this should be recycled. So all the batteries often have this sign that says recycle. It's like, please recycle it, do not discard it into the environment. Taha.
Yeah, ma'am, I just want to add one more type of substance that I read about, which was brominated flame retardants, which were included in batteries specifically to stop them from combustion for everyday use. And those are also potentially really terrible for the environment.
Exactly. Thank you, Taha. So basically, the more good it is for our use, the worse it would be in composition. So you're making it flame retardant, you're making it, waterproof, whatever you're doing, you're adding more and more chemicals to it. You're adding more and more things to it, that could simply be avoided by just keeping it into the room. So, or keeping it safe. So, these again are just a few examples of the kind of batteries, and you've already known that they're not good for your health or for the health of the environment. It's just, I think, again, coming back to, like I said, being conscious and making those small changes in your life. So if you have something running on a battery and you're just changing the battery for the sake of it, I would say just not have it in the house. Of course, in academia, in other institutions, you have to have them, so you use it, but wherever it's not needed, don't use it. And wherever you're using it, make sure that things like batteries that have all of these toxic chemicals are recycled. So yeah, and the next thing, and I think this you guys can talk about as well, is the improvement in urban planning. What are we doing to Lahore? We're expanding it laterally, horizontally, or whatever the direction is, and then we're claiming all the villages from all across, expanding the city, and guess what? The city doesn't have a wastewater treatment plant. The city doesn't have a clean water supply assessment, so that there isn't one single parent company that provides clean water to you. So WASA, if you ever speak to them, would say that this is the official boundary of Lahore that we serve to, because all the other boundary is not Lahore. It's something that has expanded and we do not provide services to this. Then these housing societies have their own water provision and wastewater, like they take care of it themselves. So having a central body to make central decisions and making it useful for the environment just becomes so difficult. And therefore, I think urbanization in particular had the most role to play in maintaining soil quality. And someone rightly mentioned that flooding has been increased. Flooding in urban areas has increased 100 times because we have reduced green spaces. We haven't left those kind of sponges in the soil where water could be infiltrated and floods could be avoided. So all of those things, I think, are because of improper planning, and they result in, if you haven't designed for your city to treat wastewater, then all your city will have is ganda nalas. If you don't design your cities for public transportation, I've put the map for London Tube in there because it literally connects the entire city to all the stations. So maybe if the remotest of places, like even a village outside of London, you could simply go to, because past that tube line, there would be a bus. Even if it goes once a day, it would be there for you to be connected to the city, which means you don't always need to drive your car. And unfortunately, the cities here have been designed for cars. They haven't been designed for people who want to walk. They haven't been designed for people who want to cycle. There are no biking lanes. There are no walking lanes. Like, where in DHA do you see walking lanes for people who are walking? They just have to save themselves from accidents and walk. So I think a lot of the soil pollution and water pollution and air pollution has to do with improper urbanization, or just everyone rushing to the cities because there are more opportunities in the cities. What should we do? Of course, we should have plans for wastewater treatment, which we will be talking about in a while. We have very little time. And then wherever we can, we should restore our landscape, give cities those green spaces that they need. And again, I'm using a few examples, and people who want to talk about anything, just raise your hands. You're more than welcome, because I would want you to be active in the class. Wetlands were mentioned in the class again and again. This particular wetland is in India, Gujarat, where they basically monitored sites. It was, yes, Taha.
Ma'am, I had a question about a thing we talked about a little while ago, which was the first case example, where in the Ivory Coast, the land was contaminated, right? So in that regard, you also mentioned that contaminated land can very often contaminate the groundwater underneath that land as well. So in that regard, like how land is restored using methods such as all those you talked about, how would you deal with the water that's underneath that land?
The water that's underneath the contaminated land?
Yeah, the groundwater.
Yeah, so like I said in the beginning, oftentimes if the soil is contaminated, the underground water is also contaminated alongside it. So when you say wash, pump, and treat, it refers to that particular system where you're washing all of it from the soil, extracting all the groundwater, bringing it to the surface, treating it there because it's difficult to treat contamination in groundwater, and then put it back. You would also use certain tools. So for example, the electroplating method, right? So you know that it would be difficult for you to, for example, go down and see what's going on. I think I put a term for you to Google, which is a machine that has the ability to go there, not only extract samples, but also treat it and monitor it. So there are those commercial mechanisms available for you to see what's going on in a particular area. But you basically, whatever method you're using, and it depends on what you choose and what's the contamination there, and how difficult is that. If it's an aquifer, if you've contaminated here, and then that aquifer just moves, and the next time, like, you will have to trace the pollutant and treat it few miles away from the city, downstream somewhere, and that depends on the flow of groundwater, right? That means that you will treat this particular part of soil separately, monitor that groundwater pollutant, extract it at a certain other point, because if it's going somewhere else, specifically if you're extracting groundwater for drinking. So let's say we have installed a well here and we are drinking water here, and a pollutant was thrown away from it. Because we're extracting water, that pollutant would come towards the drinking water source, which is why your drinking water sources should also be monitored. Because if they're close to industrial sites, that means that you're prone to these chemicals as well. So it's quite complicated, Taha. But generally, these soil remediation techniques are kind of coupled with groundwater remediation techniques as well. So yeah, I mean, that's as simply as I can put it. Okay, so for example, I'll just leave this one. Let's just go to another one. So basically, wetlands we know are those corridors for species. They were neglected in a lot of spaces, but now people are restoring it back. And wetlands can be both natural and artificial. Some wetlands are built artificially to treat wastewater. Here, I've quoted examples of 2 sites, both India and England, where there were naturally swamps and marshes and wetlands. But when the species started disappearing, that's when again they were alarmed, and that's when they started monitoring it. They started making the environment friendly for wildlife again, stopped certain activities, put in all the local plants and grasses and shrubs, and then looked at, monitored it, and saw it recover again. And like I said, these are not 1 year, 2 year, 3 year projects. These could be 1 decade, 2 decade, 3 decade projects. So imagine what would happen to our country when we start remediating it, probably 5, 6 decades. Anyways, so people had talked about geographical information system. I mentioned it somewhere. This again is an ArcGIS map where it kind of tells you that in a particular wetland, what kind of wetland are you referring to? So then the monitoring and control becomes easy. Okay, this one's the forested one, which means there will be more trees there. So what should be the conditions there? If you're looking for birds, where should you monitor those birds, etc. So the keystone species that we had looked at. It's important that these sites are monitored, these pollutant sources are taken away from them, and that these sites serve as a corridor that we require more than economic corridors. But we require economic corridors as well, but I think it's important to save our species. So I just wanted to put that word in. Now we are coming back to basic filtration techniques, because I've taught this to you, and this, I will not talk about it. It's again coming back to what we had looked at when we were looking at chemicals that could be present in wastewater, the National Environmental Quality Standards. Why is it important to have a standard? Because we do not want to lose the natural habitats such as wetlands and soil, and we do not want that kind of degradation where we end up having just barren lands or deserted lands around us, and be hit by even severe poverty. So this particular slide I'd shared with you in one of the lectures, and I'd told you to reflect on how the BOD, COD, and TSS, so total suspended solids is the turbidity of how many solids are there. So I'm moving my hands and thinking about Hassan's comment, so I'll stop moving my hands. But basically, the TSS is the total suspended solids that are there in the wastewater, and based on that, for example, if the wastewater has a lot of TSS or suspended solid, it would be difficult to treat it using light. So, for example, if the water body requires light and there's a lot of TSS in it, if the microorganisms in there require light, that means that the TSS would stop light from getting in there. So what would you do? The suspended solids are the ones that cannot settle. So if they're big enough, they should technically settle, and then you will take that one out first, and then whatever's in suspension, you'll think of ways to treat it. So as an example, and I hope this is fun, because just try and enjoy this example. I know it's complicated, but I'll try and simplify it. We're all wearing clothes. We enjoy wearing colorful clothes. I was thinking about which particular industry to bring in when I'm thinking of ways to treat the wastewater of that particular industry. And because we are a country that grows cotton, our textile has had a good reputation, I thought to bring this forward as well. So of course, every industry has a processing. That processing has a certain kind of pollutants associated with it. The treatment process depends on what kind of pollutants are present in the processing or in the raw material or in the final product that you take out of a certain industry. So in the industry, we are making a fabric, but in the process of making a fabric, we are bringing in cotton, we're bringing in plastic, we're washing them, we're using certain chemicals such as bleaching. So if we bleach it, then we'll definitely have hydrogen peroxide. You don't need to be a scientist or a chemist to know this. Everyone knows that bleaching has H2O2 in it, and it's not that good. So if you put it on a cloth, it would just decolorize it, right? So when you know that a certain chemical has that kind of ability, then you want to make sure that this chemical doesn't end up going into the environment. And for that matter, you have to treat it. Oftentimes, industries are put in what you call industrial zone, where they have a combined wastewater treatment plant so that they can take all of these things out and then send it to the city's wastewater treatment plant. Very few industries in Pakistan treat their wastewater. But if they could treat their wastewater, how would they treat it? So even for municipal wastewater and industrial wastewater, the first process is to screen it. So it would simply use a sieve, something with pores bigger, to retain all the plastic, the trash, anything else that came with it. Then you would allow for it to, the equalization tank is basically like the source tank where you put all the liquid in. Then there is sedimentation. Like I said, if it has suspended solids, they will settle, and whatever's on top is claimed and taken to the next step. You neutralize the pH. If it's acidic, you add base to it. If it's basic, you add acid to it. And then there is a process called coagulation or flocculation where now the ones that could settle have settled, and the ones that couldn't settle are suspended. So what would you do to this suspended? You would either filter it, or you would add a certain kind of chemical that would bring it together and coagulate it or make bigger flocks of it. So that's what you do in the next process. So these are primary treatment, because in this you kind of take as much suspended solid, as much chemicals away as you can. But if you look at this table, where after it has been primary treated, a lot of things have been reduced down to half. So some people who are sending their waste to a secondary treatment plant, the treatment plant of a city, might just send it with these conditions. So they may just introduce primary treatment at the industry, and then after that they would think, okay, now it matches a municipal waste or another waste, and then we can send it to the conventional treatment plant for the city. They can do that. Here, if you look at it, the BOD is still high. It has only been reduced by 25%. The rest of them have been reduced, but the BOD hasn't been reduced. So what do you do then? You now use the microorganisms or the live protozoans, anything else, algae, fungi, to utilize the nutrients, right? So that's what happens in the secondary treatment process, where it's, yes, Rafi?
Ma'am, can't you just do reverse osmosis, filter के through उसको push कर दो एक दफा?
I was waiting for someone to say this. Yes, you can, but you know what happens? The suspended solids can form a very thick film outside and sometimes steer, because what happens is there is a film growing on the wall of the filtration. So you pressure, it's a high pressure filtration system, which means you're applying a lot of pressure on this membrane, reverse osmosis membrane, to take all the clean water out, which is possible. I mean, you can reduce the pressure and clean the membrane continuously to make sure you do that. But that's, that increases the work for you, and it's expensive because it uses a lot of power. So what they would do is what they then do is, they don't use it, because the more film grows on it, or the more things settle on the membrane, the higher pressure they'll have to apply. And if they keep applying the pressure, then the membrane can just tear down. And that's exactly what happened when I went to Jordan. They had basically installed a microfiltration, not reverse osmosis, a microfiltration for membrane bioreactor. But because the strength of the wastewater was really high, it had very high COD, very high VOD, and all kinds of things in them suspended in there. They were continuously using it. And what happened was, within a year, the membrane clogged, or the pores clogged. And the administration had an issue that, it shouldn't clog in a year because they told us that the membrane will work for 10 years. And then I had to go down and explain the design principle to them and tell them that this is exactly what happens when you do not operate a wastewater treatment plant for the design conditions that you set, because they hadn't designed for the treatment plant to operate at such high concentrations. So yes, you can, and no, you cannot. It depends. So if there's any, yeah.
Like clogs in a year, so आप maintenance करें and you like change your filter after like every 9 months or so?
You can't change the filter, but you can clean it. For example, with my PhD study, what I did was I was also continuously cleaning the membrane with acid-based solutions, basic solutions, I think. I was continuously cleaning it to make sure that every time I run a process or every time I run a filtration setup, I have the membranes completely clean. So then, the pressure, the cake doesn't, so let's call it cake. So the cake doesn't build on it. But for textile, I think it's just the acidic chemicals. So it depends on the kind of chemicals. If the chemicals can damage the membrane, then you would use something else. But to be honest, that's what I would think, because I'm pro filtration. So I like the suggestion. And then, so all of these are basically just having septic tanks in the open air. So aerated lagoon is just having that tank there. The trickling filter is a bed. We've discussed this before. You're just using a medium, again, for wastewater to go through. There are bacteria there and they eat the nutrients. Slowly the water passes through and it has basically reduced the BOD remarkably. And activated sludge, it's in your books. This is the mechanism that's used for municipal wastewater treatment. So conventional wastewater treatment, I think I'll give this to you as the reading assignment. Go back to your reference books and read what this process is. It's fairly simple. And oxidation ditch, again, is something where you aerate it yourself to make sure that bacteria quickly degrade the chemical. Now, because last time I hadn't mentioned water vapors, I realized that ozone is also used as a tertiary treatment. So the last step, if you really want clean water in the environment, the last step is using things like membrane filtration. So because now the initial load is really low, the water is mostly clean, you can now use things like RO, because then you don't need to apply a lot of pressure. You can take clean water with light pressure as well. But ozone is very reactive. And because of that ability, it is used in the tertiary treatment to treat water. So any chemical that's remaining in the water still, people use ozonation to treat it. So I just wanted to mention it here before I leave you guys. And 2 more examples and then we'll finish. How much time do I have? No time at all. So oil spill, does anyone want to just guess quickly what's happening here? Basically, oil is light, it stays on top. Yes, no, Rafi, no, you've already spoken, someone else needs to speak. So oil is light, it stays on the surface, and then you can skim it and treat it. So you extract it, you treat it there, you can burn it, you can use certain chemicals such as surfactants to disperse it, because you don't want the birds and everything else who are dipping in to get all that oil. Or you can use microorganisms or adsorbents or certain kind of sorbents to take that chemical out from the environmental system as soon as possible. So, this is another example that you looked at. For eutrophication, again, was a topic that many of you like. There are many ways to treat it. One simple way could be continuously taking the algae out until the nutrients go down. The other would be to treat wastewater and make sure nutrients don't get into the water body. Another could be using ultrasonic radiations to control the algae that causes eutrophication, or harvesting fishes or putting fishes in there after skipping the algae to make sure that they eat the phytoplanktons, and then there are no phytoplanktons remaining for algae who also need to feed on this, and then kind of stopping the process of eutrophication. Should I talk about this? Okay, so this is because I've always presented algae as a monster. It's not a monster, it's just utilizing on the nutrients. This is the water supply of Oxford. So basically what they've done is used plants and cyanobacteria as a living filter to feed on any nutrients that are there. The water is generally clean, but just to make sure that when the water is coming from the watershed and entering this water supply body, so let's say it's Raval Lake of Oxford, then what happens is that they use these plants to feed on those nutrients and make the surrounding water clear, and then send it after a little bit of treatment for drinking to the city. So bigger plants at the bottom, close to their roots, there are algae that are growing there. So many slides. Why did I make so many slides? Okay. Right, so this is my PhD research, where I combined two membrane technologies to treat wastewater. So let's say that if there's wastewater or sludge going on the one side, and in this particular case, I'm using let's say a fertilizer, because it has an osmotic potential. I'm using that as a draw solute. There is a membrane in here. So one is passing from one side of the membrane, the other is passing from the other side of the membrane. What I want for it to do is for the water in this wastewater to pass through and come here in the fertilizer and then go straight to the farm. Not related to what I'm doing right now, and in any case, not related to my overall PhD, but I just used it as an example, where instead of applying things directly, you just use it in combination and use a certain technology for agriculture. I used surfactants, and instead of reverse osmosis, worked on the principle of osmosis. So I allowed for this osmotic potential here. So for the salt, so let's say this is sodium chloride. For the sodium chloride to attract water molecules because of her osmotic potential towards here, and then for only this sludge to concentrate and then be treated and used as fertilizer again as the way to extract water from wastewater. So basically, I was just asking for the water to come from the wastewater side down to the clean water side, where let's say I've just added sodium chloride. And I'm just going to conclude it here. If you have any questions, you're more than welcome to ask it. Pollutants are evolving. Pollution is evolving. The secondary impacts are evolving. The solutions are also evolving. And I think there's still a long way for us to go. I hope that all of you utilize this knowledge, whatever you've learned, use your voices to force our governments to take those strict actions that are required before, we've already messed up with our cities and villages already, but to stop further degradation, I think we should also stop it. And whatever you're doing in your labs, in your small households, in your practices, just make sure that they are environmentally conscious. And now I can take Rafe's question. Sorry for rushing through the last two slides. Yes, Rafe.
I'm in the second last slide. So was your objective to use wastewater as fertilizer water?
Yeah, okay. So I think I'll just, what have I put? Let me take this chat out. Okay. So basically my solution was two-pronged. So from the sludge, I was taking all the water out, reclaiming the water, because we often say that wastewater is 99.9% water, right? So first step would be to take the water out from this. But instead of the pressure intensive reverse osmosis, I'm using forward osmosis, what we call forward osmosis, where the salt molecules are attracting, something we read in childhood, the salt molecules are attracting water molecules from the other side. So this highly concentrated salt solution is attracting water molecules from the wastewater, and the sludge can be dried out and used as, for example, this is a company of my friend where they use this as a sludge and fertilizer for agriculture in Kenya. So I just used the example here in the slide. So one part of it is to take as much water out, let that mature, and for that to be used as a fertilizer in the field. And then on the second, like on the other side of the membrane, I have the salt, which has higher osmotic potential, and it's attracting the water molecule, but it was half clean, right? But because I had, in this particular slide, when I prepared it, I was thinking of fertilizers as draw solutes. Fertilizers can also be used as draw solutes. Salts can be used as draw solutes. Surfactants can be used as draw solutes. Polymers can be used as draw solutes. And I used all of them. But once I did this process, I had to combine it because this is half treatment, right? Now I need to reclaim this salt out. So for that, I added the membrane distillation process, which basically means that I now, once this is done, then I subject this water to heat, and the water vapors then can go with this membrane. So this membrane is water loving, this membrane is water hating. So it's only allowing for water vapors to pass through here. So I'm now, after I do this, I'm heating this stream, and I heat this stream, and past that I claim all the water in the form of gas, and that goes past the membrane, which wouldn't allow anything else. So sodium chloride is dissolved in it. The temperature, so if this is the membrane distillation membrane, I have warm feed coming in. So the sodium chloride that was diluted is going here. It's warmed a little bit. And then the vapors can pass through the membrane. Nothing else can pass through the membrane. And the temperature on this side is down. So for example, if this is 35 degree, this would be 20 degree. And then automatically those vapors would condense, and that water was clean water. And that was my PhD thesis. I don't know if I explained it better to you, but that was like the basic concept. So you use salt water to claim water from waste, and then you use that salt water, heat it up, and use the principle of membrane distillation to take only clean water out. And you're doing that using membranes, so you make sure there's nothing else passing on the other side of the membrane. So yeah. Okay, I think this is it for today. Thank you for staying. I'll put
Allah
the
Hafiz.
Allah Hafiz, Azan. And Allah Hafiz, everyone. If anyone has any question, you're more than welcome to stay back and ask.